Okay, thanks. Hi, everyone. Thanks to those in Australia who are still out of bed, assuming there are some. I know several of them have disappeared. This is some work that Jim Pettigrew and I are doing on analysis of the diagnostic test that we've been developing there. I spoke about it here last year. It's a diagnostic test to identify which subject is the correct one for students that are coming into UNSW. Pardon me. So a little bit about UNSW. It's a large university, I think about 50,000 students in Sydney. That's our campus. In fact, that's the maths building on the extreme right there. And we have several first year courses, but the three that I'm interested in for this diagnostic test are Math 1141, which is the advanced version of Maths 1A. So it's designed for students who've done the most advanced level of mathematics in year 12, and they've achieved good outcomes, a high grade in that. Maths 1131 is our standard first year, and both of these are calculus and linear algebra subjects. So 1131 is our standard entry level subject. It still assumes that students have done what we call extension 1 calculus, which is the second to top level, and have achieved good results in that. And then for students who don't reach that level, we do offer Math 1011 Fundamentals of Maths, which is actually a course that I'm coordinating this term. We still assume that students have advanced maths, so they still have some calculus, but they're not up to the level for Math 1131. At the minute, our enrolments, because we start teaching next week, our enrolments in Math 1141 were close to 1,000 students when I checked last. Math 1131 was about 2,500, and Math 1011 is only about 75. Now, there's probably quite a few students doing Math 1131 who should be starting a level lower, and similarly, quite a few of the Math 1141 will probably drop after the first week when they realise what the level of that subject really is. So the diagnostic test is based on essentially what students should know for Math 1131. So it's a subset of the syllabus for the advanced and the extension maths that's taken in New South Wales high schools. I should also say we don't have prerequisites subjects for entry to university. It's based on a tertiary education, Australian tertiary education ranking, which a student gets at the end of year 12 if they complete the year 12 examination. So a student could get an ATAR of 95 out of 100, but have not done any maths. They'll probably get an offer to university, but if they're doing something that involves maths, they're well and truly behind the 8 ball. So hence this skills check. We've gone, and it's based on the same sort of model that Emma was talking about this morning, the NUMBAS diagnostic. We've gone with seven learning outcomes, which you can see there. Functions advanced level is the area on functions from the advanced syllabus. Functions extension level is the extension from the next level up, and the same for trigonometry and calculus. And then overall, there's 137 questions, I think, in the diagnostic. That's the knowledge map. Not that it probably means a huge amount, but it's the same sort of connections as Emma was showing this morning.
Looks like the United States.
yeah, it does actually. It's a new visualization that another one of my colleagues, Joshua Capel, who was on here earlier, I'm not sure if he still is, has designed for us. A few things that we've identified since building this. Like I built this from the syllabus, and then we pruned away some areas that weren't necessary or weren't really knowledge that we assumed. But what is left are several sort of long paths that, like the blue at the bottom, there's a few others in there, and that's one of the things that's making this test probably longer than it needs to be. Because if you think about it, for a student to get 100% in this diagnostic test, they have to answer every question that's a terminal question. And they have to get to that question by moving along one of these paths. So it means that they have more questions that they need to answer. There's only 2 or 3 initial points, which are questions that don't have anything more simpler. So if they're not doing well, they only end up getting down to those 2 or 3 points. So one of the things that we've found is that a student who is going to bottom out in this test will probably only answer about 12 questions and get implied scores for all of them. But a student who gets everything correct is probably going to be asked about 70 questions. So that's one of the areas that we're looking at for improvement in this. But what I'm talking about today is some of the analysis that we've been doing. Emma mentioned a couple of things this morning, which I'm really interested to talk with her about later, because we've gone down a slightly different track of looking at some validation measures and just looking at how students work through the test. So the NUMBAS test, as Emma mentioned, drops a huge JSON file for every attempt that a student makes, and it basically allows you to reconstruct the test that they've had from scratch if you work through it. So there's a vast amount of data there. This graph is also, we also constructed this from the data that we got from the NUMBAS, the source file for the NUMBAS test. So one thing this has allowed us to do is we can rebuild exactly what the NUMBAS graph is. And we've also got the graph that we started with when we first developed the test. And so one thing that we've done is compare these two and realize that I didn't update the graph that we were using for development when I made some changes to the NUMBAS test. And so things got a little out of sequence, which is something to be careful of. But we now have the method to compare those things. The NUMBAS test gives each student a percentage for each of the learning outcomes. And for the analysis that I based this on, we had about, I think, 800 students who'd opened the test, or 800 times that the test had been opened. About 700 of those were what I'd call valid attempts. They maybe hadn't completed the test, but they'd done a reasonable amount of it. These are our average percentages for each of the learning outcomes. No huge surprises, although I'm a little bit surprised that the extension trig is so poorly understood. The calculus, of course, are the harder sections of what we're diagnosing, so I'd expect that more students would have more issues there and get lower grades or lower marks overall. So yeah, the student gets fed back a report which gives them their individual percentages for each of these learning outcomes. We've said students who achieve at least 50% in each of the extension learning outcomes are probably okay to go on to Math 1141 as long as they've prepared to work. I think we said 60 or 70% if they want to be fairly sure, and about 40% for Math 1131. If they get less than that, they should really think about taking the Math 1011 foundation course. So we don't know yet how many students are going to follow that advice because it is purely advice. And we're also planning to add resources to this. So when students do this, they can then, if they don't score well in an area, we'll have resources for them to go and develop those areas. Possibly not quite as sophisticated as what you've got, Alison, but heading in that direction. The other thing that we've looked at is the number of questions that students are asked directly compared to the number of questions that we have implied scores for. So again, to reiterate, the way the scoring works in NUMBAS, you're asked a question, which, you know, there's an initial question which everybody starts in the same place. If you get that question correct, then you're moved along a pathway to questions that are more involved than that question until you reach a point where you get that incorrect, or you reach the end of one of those terminal points, at which point it will jump to another question in a different area and then follow the same process. If you get a question wrong, then if you get the question right, then any question which is below that question, or actually above it in the that sits higher than it in this graph, would be marked as correct. That's linked to it. So you get if you answer the first question incorrectly, there's a whole lot of implied scoring that happens for the questions that are higher than this. And if you get it correct, again, there's a whole lot of questions that are marked as correct. So the number of questions that students get asked sort of follows this pattern. The color coding on this is also a measure of how many questions overall the student was given marked as correct. So purple is, dark purple is 0 correct, bright yellow is they got everything correct, all 137 questions. So it looks like there's some sort of an exponential growth there that maybe we can investigate a little more. I think really somewhere between 40 and 50 questions in this test is giving us a pretty good measure of where the students are, and perhaps we should be stopping it after that point. Again, this is something that we can look at as we go down the road of developing this, but being able to extract this data, and we've been using R to do all of this, is valuable for validation and for checking. The other thing that we've done, which somebody mentioned in a question earlier this morning, was Rasch analysis. A Rasch analysis assumes that all questions are on a single scale and grades those questions based not only on the percentage correct students who answered them correctly, but also on the students' abilities that have answered the question. So there's some, I don't entirely understand the process, but it seems to work. It's well recognized. And what we've done is to do Rasch analysis on the questions which the students have been asked directly. So questions where students have actually answered the question directly, and the implied scores. So the scores, the percentage is correct for the questions in their implied score. And then we compare those two. Now, the two scales are not immediately comparable in terms of their numeric values, but in terms of the ordering of questions, we would expect to see a fairly similar sequence. So what we've looked at is the difference between the measures, and anything that has a large measure of difference, either positive or negative, we can then imply, well, either the students who are getting this question directly are doing worse at it than the implied score is, or vice versa. And that then is a measure for us to take a look at that question and see, is there a problem with the question wording? Is it a question that we should expect this to happen, or what else? And so modify the questions. And I think that's about all I have to say for this. But I think this process of refinement and development of diagnostic tests, particularly if we're developing bespoke ones, is something that needs to be done sort of until it settles down and we're happy with where it is. If anybody's interested in sharing this sort of analysis, the R scripts that I've got at the minute are in a bit of a mess. Jim and I have written them, but we've sort of written them as we go, and so we come back to look at it and say, what were we doing here? So we've still got to sit down and document it and make it a little more general so that another NUMBAS test could use it. But that's certainly our aim to do. So again, if there's anybody that's using a NUMBAS diagnostic test and is interested in what we're doing, I'm more than happy to to work with those.